Okay, so here we've got a circle with 6 points marked around the edge. And what we're going to do, we're going to add some lines across the circle like this. As we add lines to the circle, we subdivide it into various different regions. Okay? And we can, as we add more and more lines, we get more and more regions. And so the question is, once we've added all the possible lines, how many regions do we get? So to understand that, let's go back to the beginning where we've got no lines. And we've got this little table here. And here in the little table, we're going to keep track of the number of lines, L, the number of crossings. So these are the kind of internal crossings in the middle. So like this pink spot here, that's a crossing between these two lines. So we're going to keep track of those. That's the number of crossings is going to be C. And we're going to keep track of the number R of regions. So at the moment, starting at the beginning, we haven't added any lines, so we've just got a single region for the whole of the interior of the disk. And as well as keeping track of L, C, and R, we're going to keep track of this combination, R minus C minus L. So at the moment, no lines, L is 0, no crossings, C is 0, one region, R is 1, and so this R minus C minus L is equal to 1. Okay, so let's add a line. Let's add this one, say. So now we've got added one line, there's still no crossings, so C is 0. And because we added one line, we split this main region into two different regions, so now we've got two regions. But if we look at R minus C minus L, 2 minus 0 minus 1, that's still equal to 1. So now let's add another line. Okay, we add the line from 3 to 6. Okay, so now what's happened? So we've added a second line, so L's gone up to 2. And we've added one crossing in the middle, so C's gone up to 1. And now, we've split, we used to have two regions, but each of the two regions has now been split in two. So we've got two extra regions, 4 regions in total. But we find that if we look at R minus C minus L, so that's 4 minus 1 minus 2, that's still equal to 1. So let's add another line, like here, say. Okay, so again, so now every time we click one of these, the L's going to go up by 1. And in this case, C has gone up by 1 again. R, well, you look at it, now we've got, now there's 6 regions. So R is up to 6, but still R minus C minus L is equal to 1. And let's do something else. Let's put in the line from 2 to 5 here. Okay, so this time we added 2 crossings. Yeah, we added 2 crossings. Added one line, so L's gone up to 4, 2 crossings, C's gone up to 4, and R's gone up to 9, but still we see that R minus C minus L is equal to 1. So we should try to understand why R minus C minus L is not changing. Okay, so let's go back here. So we added this line from 2 to 5. Okay. So as always, L's going up by 1. And C's going up by 2, right? So there's these 2 new crossings here, which means that those 2 new crossings, they're splitting our new line into 3 sections. Okay, the number of sections of the line is always going to be 1 more than the number of new crossings. So 2 new crossings, and you get 3 sections of the line. Now each of these sections cuts across one of the old regions, and so it splits that region into 2. So each section creates a new region for us by splitting one of the old regions into 2. So the number of new regions is equal to the number of sections, which is 1 more than the number of crossings. So, so the number of crossings goes up by a certain amount, and R goes up by 1 more than that. So R minus C is increasing by 1, but this was when we added an extra line, so L increases by 1. So if the number of new crossings is K, then C goes up by K, L goes up by 1, R goes up by K plus 1. It all cancels out. R minus C minus L is going to be unchanged. And that that works for every line, right? Okay, I mean, even works in, here's a kind of degenerate case. We add the a new sign from 4 to 5. Okay, so there's no new crossings there. But still, there's no new crossings. That means that the whole line is just one section, and it only passes through one region and splits that one region into 2. So L goes up by 1, C goes up by 0, it doesn't change, and R goes up by 1. And so in the combination R minus C minus L, nothing changes. And that happens every time. We get, as we click all these buttons, all the L, C, and R numbers, they all change in various ways, but the R minus C minus L never changes. It's always just equal to 1. Okay. Okay, so now we've got to the end. We've added all the lines in, and how many regions have we got? Okay, so well, we know that r minus c minus l is still equal to 1. R minus c minus l started off being 1 and it never changed, so it's still equal to 1. So r is 1 plus c plus l. Okay. So what about c and l? How do we understand those? Okay, so let's have a look at crossing here. Okay, so the crossing is the crossing of two lines, and those lines they come from 4 different points around the edge of the circle. Okay, so for each crossing point here, that comes from 2 lines, and those 2 lines come from four points. And if you think about it, it's going to work that way for any possible choice of 4 points. You know, if you've got points A, B, C, D in order, then you've got a line from A to C, a line from B to D, and those are going to cross somewhere in the middle, and that gives you 1 crossing point. So you get so you get 1 crossing point for every subset of the vertices of size 4. So in this case, you've got 6 vertices, so 6 choose 4 crossings. So that's our C. C is going to be 6 choose 4, or n choose 4 if we had n points to start with. And what about the lines? Well, the lines are actually easier. I mean, line is just determined by its 2 endpoints, right? You choose any 2 of our n points around the circle, 6 points in this case, and so that gives you a line. So the number of lines is 6 choose 2. Okay, so now here we are at the end. Our L is going to be 6 choose 2, C is going to be 6 choose 4, and R is going to be 1 plus C plus L, so it's 1 plus 6 choose 2 plus 6 choose 4. Okay, and it's going to work out in this case that that's equal to 31. Yeah, and in general, if we had started with n points around this circumference of the circle, and we join them all up by as many lines as possible, and then count the crossings and so on, and count the regions, it's always going to work out that the number of regions is 1 plus n choose 2 plus n choose 4.